All right. Hello, everyone. This is Mr. Burdett once again. Today, as you can tell by my topic, is going to be on division by fractions. I chose this particular topic because a lot of my students have come to me on different occasions and asked me, Mr. Burdett, why when we doing division by fractions or division with fractions, do we end up doing multiplication? Can you help me understand why that works? And then I say to them, first I try to, get them to think about it, but then I think about the fact that it is one of the most complex forms of arithmetic as far as our operations, and it's one of the most just a complex. You have to have it's a very complex form of arithmetic, and it takes a deep understanding to understand why when we dividing with fractions that you end up multiplying to get a quick answer, and why it works. Understanding why it works it takes a little bit of thought. So I'm going to try to run some of my students through that train of thought, and maybe even some teachers may adopt the same approach so students can reason better why they may be doing what they're doing when dividing with fractions. So what I'm going to do is this. We're going to start off with some basic whole number fractions. We're not going to start off with no fractions. Let's start off with some basic whole numbers, and we're going to look at some trends as we go along the way. In other words, we're about to analyze some patterns and things of that nature. So I'm going to keep this white here. Let's say we had 8 divided by 2. Now, we know the answer would be what? 4. Now, this is a division of whole numbers. Division with whole numbers. This is not hard. It doesn't take a lot of thinking. But there is something that we can get from it that will help us understand the division of fractions. And let's try to gather those thoughts or that understanding. First, let's define the various parts. We're going to call this exactly what it is. It's called a dividend. Dividend. This here number in the back or behind this division sign is called the divisor. Does the dividing. And this answer that you get when you divide 8 divided by 2 is called a exactly quotient. So I'm going to make reference to what the parts of this division problem is called. Sometimes we're just going to call it the left and the right. Okay. Nevertheless, let's say we had 8 divided by 2. We know the quotient that we get is 4. Now, what if we had 8 divided by 2 and what if we just wanted to experiment and see if something actually worked or didn't work? What if we multiplied this dividend on the left by 3, and then we multiplied this divisor by 3? What would be our new division problem? We would get what? 24, because 3 times 8 is 24, divided by what? 2 times 3 is what? 6 is equal to what? Yep, 4. So we actually get 4. So 8 divided by 2 is 4. When we multiply the dividend and the divisor by the same value, in this case 3 on each side, then we ended up getting a division problem of 24 divided by 6, and it actually come out to be 4 for a quotient as well. Now we know 8 divided by 2 is one situation, and 24 divided by 6 models another type of situation. However, the value that they both yield or pop out is 4. Okay, so there are 4 2s in 8, but there are 4 6s in 24. So we're focusing on the fact that we multiplied the dividend and the divisor by the same exact number, and we ended up getting a quotient that was the same quotient of 4. Now let's see if this holds up. Let's try another problem. Let's say we had 10 divided by 5. Okay? Equal. Now we know what we're going to get. We're going to get 2 for a quotient. Now let's try multiplying the left and the right by a similar number and see if we end up with a quotient of 2. Okay, let's see if this holds up. Let's multiply this dividend by 4. Okay, let's multiply this 5 by 4. Okay, what would be our new division problem? 40 divided by what? 20 is obviously what, you all? 2. Exactly. We ended up with the same quotient. So there's something going on. If we multiply the left, which is our dividend, and the right, our divisor, by a similar number, we're going to end up getting a quotient that is equivalent to the original division problem. 10 divided by 5 yields 2, and 40 divided by 20 yields 2. So maybe we can carry this same concept of thought to the division of fraction. So we're maintaining the value of our what? Quotients. So let's make sure we write that down. This is called maintaining, which is mean keeping, maintaining the value of a quotient or division problem answer, a quotient. How do we maintain the value of our quotients up here? We multiply the dividend and the divisor by a similar number. Okay, I'm gonna try to get one more on this page. Let's say we had 12 divided by 3. Okay, I'm gonna set it up like this. Now that's the same thing as what? 12 divided by 3, correct? So these are different, same ways of writing it. Now let's say I divide at the top by 3, which is our dividend, and our bottom number by 3, which will be our divisor. In this situation over here, we call it numerator and denominator. We can say that as well. We would end up getting what? 4 divided by what? 1, which is equal to what? 4. Because 12 divided by 3 is 4. 3 divided by 3 is 1. That's 4 divided by 1. So 12 divided by 3 is equivalent to 4 divided by 1. Notice we divided the dividend, in this case our numerator, and the denominator, which is like our divisor, by the same number of 3, and we ended up with an answer of 4 in each case. 12 divided by 3 is 4, and 4 divided by 1 gave us 4. Now we are trying to maintain the value of our quotient. Okay, now do we always have to multiply? No. As you can see in this case down here at the bottom, Mr. Burdette divided the top and the bottom by 3, which was just like dividing by 1. And anything divided by 1 is itself. So when we got 4 over 1, 4 over 1 is just an equivalent fraction to 12 over 3. How do we know that? Because we just divided 12 over 3 by 1. Now, I want to stay with the multiplication aspect of it. So let's go to some division of fractions, and we're going to try to apply doing the same thing to the dividend and doing the same thing to the what? Divisor, to create another type of problem that we can work with. Let's go with this file. No, I'll just close it. I'll just cancel. I'm gonna start a new sheet. Okay. All right. So let's say we had division with fractions. So let's say we had a division problem of 1/2 divided by 1/4. Now remember, my students are asking me why are they changing this to multiplication and flipping this second fraction upside down to do a multiplication problem when you're looking at a division problem. Well, let's try to figure out why that happens or why it works. Okay, let's go ahead and rewrite this. I'm not going to mess with the original. So if we want to find an answer to 1/2 divided by 1/4, let's use that same train of thought from the previous slide on this one. Now, how about if we let's multiply the left and the right by the same number. Okay, let's be smart about this. Mr. Burdette is going to actually multiply 1/4 times 4/1, so it can actually turn to the number 1. They'll cancel out. Okay, so I'm going to be smart about this, and I want you to be smart about it. Okay, now if I multiply this divisor by 4/1, then I'm going to multiply the dividend by 4/1, so I can maintain the value of my division problem. So if we look at this closely, very closely, we'll see that in the back, like I said before, this is going to really pretty much turn into 1, because 1 times 4 is 4, 4 times 1 is 4, 4/4 is 1. So basically, the answer to this red division problem and this white division problem up here turns out to just simply be this right here. This math right here. So I'm going to commute this. I'm going to say 1/2, which is the red part. I'm going to use red. I am going to use red. 1/2 times our 4/1. Did you just see how this division problem came out to be a multiplication problem? The answer to 1/2 divided by 1/4 pretty much lie in our ability to just multiply 1/2 times 4/1. Many of us would rather multiply fractions rather than divide them. And we just found a way to change a division of fraction problems or division by fraction problem to a multiplication by fractions problem. So our answer to 1/2 divided by 1/4 is simply going to be 1 times 4, which is 4, and 2 times 1, which is 2. And 4 divided by 2 is 2. So what is this saying? How many fourths are in 1/2? There are 2 fourths in 1/2. 2 fourths are in 1/2. Let's visually visit that real quick. Let's say we had a circle. And in this circle, I'm going to try to split it up evenly because it should be equal slices. I tried to split it up evenly. Now, let's just say we're going to shade in 1/2. There go our 1/2. Now, the question is, was asking us how many of these slices are in here. Well, here's half right here. What is each one of these slices called? A fourth. Exactly. 1/4, 2/4, 3/4, 4/4. Well, if this is 1/2, how many fourths are in this red part? 1/4, 2/4. So it's 2 fourths. So it's 2 of them. So 2 fourths are in 1/2. So this 2 represents this. 2 represents 2 1/4 or 2/1/4 are 2. I'm going to rewrite that. 2/1/4 are in 1/2. 2/4 are in 1/2. All right. So let's do another one. I want you to get the habit of this. Mr. Burdett is trying to show you how we change this division problem to a multiplication problem of fractions and why it's justified. I'm just trying to get you all to see this. We're going to have to do more than one for you to see it. But you're going to have to remember that all we're doing is doing one thing to the divisor and doing the same thing to the dividend. So let's take the fraction of let's say 3/4 divided by 2/3. Now I don't know about you, but I don't like this division of fraction stuff because it can get confusing. It can get complex, especially when you just can't divide them real easily. And in order to do this, we can draw it out and try to visually do it, but then that would take forever. So what we can do is use our understanding of how to maintain the value of a division problem so we can maintain the value of our quotient. Equivalent. We create equivalent division problems. All right. So what we're going to do with this 3/4, I'm going to write this 3/4 in white. I'm going to write it over. Divided by, give myself some space, divided by 2/3. Now, what Mr. Burdett said, and what we're going to do is we're going to multiply this divisor by something that will make it 1. What we're going to do to make it 1? You multiply it by the flip, right? Or the reciprocal. So we can multiply it by 3/2. That's going to make this 1. But if we multiply the right side by 3/2, we got to multiply this left side by what? 3/2. Pay attention to the structure of this problem now. This white part was our division problem that we have up here. Now the fact that this just turns out to be 1 really don't affect anything in relation to this problem. So what our problem really becomes is this multiplication over here on the left. Yep. So to divide 3/4 by 2/3, if we want to figure out our quotient to that, our answer or our quotient to that, simply we can do the division problem of, I like to commute this. I like to put what we see first. It don't make a difference. I could write it like that. But I'm going to put, we can simply just go ahead and do this multiplication problem of 3/4 times, that was in red, so I'm going to keep it in red, 3/2. This multiplication problem is equivalent to getting the answer to this division problem. That's why this equal sign is setting these two equal to one another. Look at this again. We multiplied the right by 3/2, so we can make 2/3 cancel out and become 1. And then we multiplied the left by 3/2 as well. So the answer to 3/4 divided by 2/3 is simply 3/2 times 3/4. It went from a division problem to a multiplication problem. And I, like many people, would rather multiply this. We get 9/8 rather than try to divide this out. So 9/8 turns into 1 1/8. So how many 2/3 are in 3/4? Well, this tells us right here. 1/2 2/3 exists in 3/4, and then 1/8 of this 2/3 is in 3/4, which means a fraction of 2/3 is in 3/4. All right. So this is why people are coming up with keep, change, flip crap. I don't like them. I don't like people saying that. I like manipulating the right and the left by the same value so that we can create an equivalent multiplication problem that will help us solve our division or fraction problems. I do not like that keep, change, flip, because when kids start doing it, they do it so much. If they actually explain why it works, they don't understand anything about maintaining the value of a division problem or maintaining the value of a quotient. Okay, so let's go back. Okay, I'm gonna take you one last trip to a simple problem, and then we're gonna go to another division problem so that we can understand why what we're doing is working once again. So let's say we had 15 divided by 3. Okay, I'm gonna write it like this: 15 divided by 3. We know 15 divided by 3 is what, guys? Ladies, 5. All right, so 15 divided by 3 is 5. What is another division problem that will give us a quotient of 5? Well, let's find one by multiplying the dividend and the divisor by the same number. We can also divide the dividend and divisor, but I just want to choose multiplication right now. So I'm going to multiply the left by, I'm going to keep it simple, 2. And I'm going to multiply the right by 2. And then my new division problem is going to turn out to be 30 divided by 6. And 30 divided by 6 is what? 5. So 15 divided by 3 is equal to 30 divided by 6. They may be different type of situations, but they give us the same value of 5 when you divide them. Okay, so let's do one last problem. Let's take it back to the division of fractions. Now let's say we had 1 3/4 divided by 1/2. Okay, now let's use our understanding of maintaining the value of a quotient, multiplying the left and the right by the same value to create an equivalent problem that will give us the answer to this. Now, I don't know what the answer, well, yes I do, I'm not gonna even lie. I do know what the answer to this is because I know how to convert. I can see it in my head. But for those people who cannot, let's give them another strategy. So let's try to convert this to an improper fraction so it can make it easier. You're probably thinking the same thing. Let's put it 7 over what? 4 divided by 1/2. Okay? Or 1/2. Okay? Now, what are we going to do to the left and the right? If we're going to do this division of fractions or division by fractions problem, we might want to try to change this divisor to the number 1. So let's multiply it by its what? Reciprocal. Okay, which would be what? 2/1. But if we multiply the divisor by its reciprocal, then we have to multiply the dividend by what? It's what? Reciprocal. The same reciprocal. So we multiply the right by 2/1. We multiply the left by what? 2/1. If this 1/2, if this blue 1/2 right here was 3/5, we want to multiply by 5/3 over here and 5/3 over there. So if you're wondering What if it was something else? Then that's the situation. So what's our new division problem that's going to give us the answer to this? Well, simply we can see it would be 1/2 times 1/2 times, 2 over 1 over here, which give us the answer of 2 over 2, which is 1. So this really is not playing a role in our division problem. What our division problem turned into is this multiplication problem over here. Because once we get the answer to this divided by 1 is just going to be whatever we did over here on the left. So basically, 1 3/4 divided by 1/2 is equal to, I'm going to write the blue portion first. I don't have to. I could write the 2 over 1 first, but I like to put this first. 7 over 4 times that 2 over what? 1 here. You see how our division problem just turned into a multiplication problem. So let's execute this multiplication problem. 7 times 2 is 14. 14 over 4 is 14/4, or 14 divided by 4. 4 going to 14, how many times? 3 times, with a remainder of 2 over 4, which is equal to 3 1/2. Okay, cool beans. All right, so last but not least, I'm just going to try to draw this out for you real quick so you can understand this. This is how I mentally figured out the answer before we did this in my head. So I just want to give you an idea of how to think about this. Okay, since this is split up into this is 1 3/4, so I'm gonna split everything into 4s. Okay, 1 3/4 divided into halves. Well, okay, I'm gonna shade this, shade that, shade that, shade that, shade that, shade that, and I'm gonna shade that. So this is 1 3/4 basically. Now these circles should be split up evenly. Bear with me, okay? Now how many halves do you see in here? Well, I know these two make up a half, so I'm just gonna these two make up a half. Okay, that's 1. And these two make up another half, so I'm gonna put 2. Okay, here's another set of half. This to make up a half, that's 3. So this is where that 3 come from. You got 1 pair of halves, 2 halves, 3 halves, and 1 3/4. But I can't get another. I can't get another half. But I do have half of what I need, so that's why we got half. We may not be able to get a whole nother half, but we can get half of this. Look at this. This one little piece is half of what I need. So that's why you get the half. So there are 1, 2, 3. This is 3. This represents 3 halves, and half of a half is in 1 3/4. I'm gonna say that again. This says 3. There are 3. How many halves are in 1 3/4? There are 3 halves, 3 pairs of halves, or 3 sets of halves, and then half of a half in 3/4. Okay, just half of what you need as far as a half of it. Okay, basically, hopefully you all understand how to maintain the value of a quotient. That keep, change, flip crap basically comes from understanding this right here. It should come from understanding this here. Maintaining the value of a quotient. All right, talk to you later. Bye-bye.